So, did you see on the other end of the table here?
I did. This is Ben. We have Ben
Smith.
back.
Yeah, back
You
in.
missed us so much. You had to come back. I love this.
I was fighting my way back.
Yep.
Tried
I
to
like
keep me out.
Ben Smith back to
won't
the
be
table.
able to.
You cannot stop a Ben Smith.
Perfect. And you're also going to be talking to us about Lambda.
Yeah, it
and
follows
how to
on-
build interactive applications.
Follows on quite nicely. It's almost like it was planned.
Oh my God.
Yeah.
Yeah, well, we are all about planning here. We've been saying this all day.
It has been a constant theme all day. Yes,
So,
it has.
Perfect.
Ben, we're going to turn it over to you. Talk to us about interactive applications.
Thanks very much. And I might even pull you guys in, put you on the spot
should stay here.
later on. Yeah, so please stay there.
Don't go anywhere.
All right.
Hi everyone, my name's Ben Smith. I'm a Principal Developer Advocate for Serverless at AWS. And I'm going to be talking about building interactive applications with AWS Lambda. Now, before I jump into different ways of building interactive applications with Lambda, I want to quickly define what I mean when I say an interactive Lambda-based application, right? So for the purposes of this little talk, I'm going to say an interactive Lambda application is one where that Lambda function is invoked using an HTTP request and returns back an HTTP response, okay? So that's my interactive Lambda-based application. And this is actually a synchronous invocation or a synchronous workload, right? This is something really common in building applications. I think we've even seen a similar diagram like this earlier on today. But essentially what you have is a client that invokes a service or makes a call to a service. That service might run some compute, run some logic. It might call out downstream to another service. And then it will wait to hear back from that service before eventually returning the overall result or response back to that calling client, right? Then in contrast, you've got the asynchronous request mode, which looks more like this. Client sends a request to service A. Service A sends an acknowledgement of that request back to the client before then going on and sending that process downstream to service B. Now, the crucial thing with the asynchronous mode is that you don't actually get the response back to the client unless you query that by some other means, right? The other thing to note is represented by this little pink line, and this is the blocking time, okay? It's the time that the client spends waiting to hear a response back from that service A before it can move on to the next procedure. So when we talk about building Lambda-based applications and in terms of synchronous and asynchronous invocations, it's, I think, helpful to understand a little bit about some of the processes and some of the ways that that Lambda function is being invoked under the hood, right? So we'll take a synchronous invocation via an HTTP request, and I'm going to use Amazon API Gateway as the example here. So you send a request to your Lambda function via Amazon API Gateway. The first thing that does, once it passes through API Gateway and proxies on to the Lambda service, is under the hood actually hits this front-end API, right? Now, this is completely obfuscated from you, the developer, the customer. You don't have to worry about this. You don't have to really think about it. But this is what's happening that the Lambda service is doing for you. So that request goes on to the front-end API. The front-end API will then send off to another request, which is responsible for finding an execution environment to run your Lambda function. Now, this can be an execution environment that's already set up with your code installed into it and ready to run, sometimes known as a warm start. Or maybe there's no execution environment that's appropriately available, so it has to find, spin up that environment, load your code into it, run your code, and return the response. And that's sometimes referred to as a cold start. So this is really useful when you need an immediate response from your Lambda functions, or if you need to return the error and catch that back on the front end. Then you've got, by contrast, this asynchronous request mode. And so this can be invoked by something like an event from EventBridge. So here, Amazon EventBridge will still route on via a rule that requests to the Lambda service, and that still goes to the front-end API. But the difference here is that the front-end API first routes that request onto this internal queue. And then the Lambda service is responsible for pulling that invocation request off that internal queue. And it only sends back an acknowledgement to the callee service, in this case EventBridge, to let that service know that it's received the request. Now, if there's an error with invoking that Lambda function, then that error actually sends the invocation request back onto the internal queue for a retry. And it can retry up to 2 times. So that's your 3 invokes in total. And that internal queue can actually persist your invocation request for up to 6 hours, right? After that point, if you still have not successfully invoked your Lambda function, then you have other options like sending that downstream to a dead letter queue. So that's what it looks like under the hood. So it's really important when you're building your serverless applications with Lambda that you decide, first of all, how you want to invoke your Lambda function. Do you need a synchronous request or do you need an asynchronous invocation? And really the first thing to consider is, do you actually have to wait for the response back from your Lambda function? And quite often with serverless applications or with Lambda-based applications, more often than you'll realize, you normally don't actually. You can process things asynchronously and then retrieve that result later. But of course, there's many instances where you do, and that's what we're going to focus on for the rest of this session here. Now, what types of interactive-based Lambda applications can you build? Well, it will be easier to ask what types of applications can you not build with an interactive Lambda-based invocation. So simple things like connecting two applications together. I think that's a really nice use case. Things like webhooks that connect one app to another. You can extend existing applications. Maybe they're already running on-prem or in containers, and you can extend that using a Lambda function. You can actually trigger asynchronous workloads via a synchronous invocation. So maybe you invoke your Lambda function using API Gateway with your HTTP request, and then that Lambda function triggers other events in your AWS account which run asynchronously. You can do things like machine learning inferencing. You can build web applications. You can create back-end applications. You've got chatbots. Of course, Alexa skills is massively reliant on Lambda-based applications as well. Now, obviously, I don't have time to go through each one of these in detail, so I'm going to focus on what I think is a really nice, simple example for getting started with Lambda. And that's connecting two applications together using a Lambda function in the middle. And there's actually an entire blog series on this, which uses SAM, as Eric was talking about earlier on, and takes you from start to finish with all the code available in GitHub. So this is a great place to get started with building out synchronous, interactive Lambda-based applications. What this little application does is whenever you start a GitHub repository, it actually posts some information about that event to a Slack channel, so you can keep track of the engagement with your various GitHub repositories, right? And here's an example of what that Slack message will look like. It says, there's a new GitHub star for this repository. It tells me how many stars my repository now has, and it tells me the name or the profile of the person that made that star event. This is what it looks like in real time, right? So on the right, I have my GitHub repository, and on the left is my Slack channel. And if you follow my cursor here, I just go up and I click on the star icon. And within a second or two, my Lambda function has posted that event out to my Slack channel. So let's have a look at what actually just happened here, right? There's some business logic here. Where is it? How is it invoked? What is it doing? Who am I? So the business logic is loosely defined, I would say, as doing something to some data to produce a valuable output. And this isn't just a serverless thing, right? This is how we've been building applications since applications have been being built, right? You have an input, a process, and an output. And this, of course, still exists when you're building with Lambda. So I just want to show what the input, the process, and the output is with this simple little webhook application. So the input, sometimes called the event payload when you're talking about Lambda, it looks a little bit like this. This is just a subset of that input. Of course, there's way more data that's being posted to our Lambda function. But GitHub is essentially sending to my Lambda function some information about the repository, the name of the repository, the number of stars it has, and the name of the person that just did that action. Now that comes into my Lambda function as something called the event object. And I can retrieve and use this event object in my exports handler, right? And this is now the process part of my Lambda function. So in this little Lambda function, all I'm really doing is reorganizing that data and reshaping it into a way that I know Slack will understand. So I've created something called a message const here, which is just a little object which I then post out to Slack using a node library called Axios, which is just sending an HTTP post directly back out to Slack for me. And then I return the response, which is my output here. And this is just a 200 status code with the result of that post to Slack. Now, interestingly, this is an asynchronous post to Slack because Slack just returns the acknowledgement to me, not the actual final result. So you're seeing this happening in all these different applications, right? Synchronous and asynchronous working nicely together. So here's the bit that's missing there, is how did that event payload with information about GitHub, how did that get from GitHub to my actual Lambda function, okay? So this is driven by GitHub's, in this case, by GitHub's webhook mechanism, right? But I need to tell GitHub how to access my Lambda function. Now, in this case, I use Amazon API Gateway, right? So I use Amazon API Gateway to create this front door to my Lambda function, and I can authenticate and authorize this front door. It's actually a URL, right? It's a simple REST-based URL that I can use to access my Lambda function business logic. And I just put that URL into my GitHub webhook configuration. Now, that's great, that works nicely, it scales well, there's all sorts of fantastic advantages to using API Gateway. But for a simple little use case like this, customers were looking for even simpler ways to access their Lambda function business logic using URLs. So we announced something called Lambda function URLs, and this is a new, simpler way of generating a URL to access that Lambda function business logic. And it's a synchronous invocation of my Lambda function. And I just want to compare it to some other synchronous ways of invoking Lambda, right? So I have the 3 players I'm going to talk about here is Amazon API Gateway REST APIs, Application Load Balancer, or ALB, and my AWS Lambda function URLs. Now, there's lots of different ways and different matrices I can compare these by, but these are the ones that I think are important to me, at least, when I was building this application, right? So first of all is HTTP-based URLs, right? I can create HTTP-based URLs with Application Load Balancer, but not with REST APIs or function URLs. I can create HTTPS URLs with all 3 of these. Now, I can authenticate and authorize access to my function URL for Lambda using IAM permissions, okay? Or I can have that completely open and public. I can't do that with Application Load Balancer, and with REST APIs and API Gateway, I have lots of different options for authenticating and authorizing access to that URL. The payload limit when used with Lambda functions is 6 megabytes across all 3, but now it starts to get interesting, right? The max timeout for API Gateway is 29 seconds, whereas since AWS Lambda function URLs are actually part of the Lambda service itself, I don't have an additional timeout limit, right? So I'm actually using Lambda's timeout limit of 15 minutes. So that means my Lambda function, if it takes 15 minutes to finish executing, then my URL can hold that connection for 15 minutes before receiving the response. SDK generation. It's, I think, a little known fact that Amazon API Gateway can actually generate SDKs directly from the service, right? I've not seen many people use it, but I think it's incredible.
Yeah, it's a powerful, very powerful feature.
Yeah, have you used it for anything?
I have. Yeah, you generate an SDK client, especially when you need to do some special auth, or you need to do when you're doing SIG v4.
Yep.
So you can generate the client, it's built into that client, then you have SIG v4 from your client.
Nice, okay,
Yeah.
well, we'll have a look at some SIG v4 stuff in a minute.
Yeah.
The cost is an interesting point as well, right? So each of these have a cost associated with them apart from Lambda function URLs. Because it's part of the Lambda service, to access that Lambda function is free. You still pay for the Lambda invocation, but you don't pay for accessing it, right? So that's a really interesting point. So this is just my breakdown of when I might use one versus the other. Of course, this is very much open to various opinions, right? But I would say API Gateway is great for using service integrations. It's not a point I actually mentioned, but with API Gateway, you can call directly to a number of different services without having to invoke a Lambda function. And you can do that using VTL, velocity templating language, right? It's actually a really fantastic way of invoking other services without needing a compute service in between if you don't need to compute anything. That also helps you reduce the amount of code in your application, right? You can also build WebSocket APIs with API Gateway. And you have this added security by lots of different ways of authenticating your URL. Application Load Balancer is really nice for migrating your application to serverless, or having an application where you want to have the same service to access your business logic, but some of your business logic is in Lambda and some of it is in another compute service, right? So Application Load Balancer is a really good option if you're starting to migrate away. Then you have Lambda function URLs, which are ideal for getting started because they're so simple to use. Simple invocations, I think they're great for. Web applications are also ideal for. And of course, longer running workloads, thanks Eric, because you have that 15-minute timeout. Okay, CORS. Eric, this is one of my favorite quotes from Eric. If cause had a face, I'd punch it in the nose. Eric, can you tell us what is cause and why you don't like it?
Yes. I don't.
Wait,
yeah.
who does like
Take a
it?
breath, yeah.
Yeah, yeah. Sorry, I was dying over here on this side of the table. So CORS is cross-origin resource scripting. It's enforced at the browser, which is
Yes.
very confusing to people.
Lots of people get that bit
Yeah,
wrong,
yeah.
right?
It's not a server problem.
It's client.
It's a communication problem. The client not understanding what's coming back. And the most important thing I'll tell you here is the sentiment still stands. Here and Ben, I believe you have been quoted saying, "I would hold CORS down."
Yeah, I'd hold it for you.
I'd like to jump in here and like after you're done holding CORS down, you're done punching it. I'm going to come in with a few kicks.
That's
and
right.
I'm just going to say that.
That's right.
I think that another quote I heard is, "Well, if you think you understand cause, you don't understand cause," right?
That's right.
Yeah. So this problem of accessing your business logic with HTTP or with a URL often brings up all sorts of interesting cause errors. And the reason I bring this up is because function URLs actually has a really nice way of handling cause. They have an editable form that allows you to set all your response headers and all your sort of allow headers and methods and paths in that cause header response. So that's like a really nice way of getting around this really painful thing that is cause. I want to do a couple of demos, right? So the first demo I'm going to show you is just very simple. I'm going to use a Lambda function URL to trigger a Lambda function that will run a scan query on my DynamoDB table, right? So a scan query, it takes quite a long time because it actually has to go through the entire table before it can return a response. So it's not always the best way to get data from DynamoDB.
Can you blow that up?
I was just going to ask that too.
Blow which up?
Your
Yeah,
screen.
sure. I don't think I'm on the demo yet, though. I'm still
Okay.
on the. Yeah, I will blow it up.
We're jumping ahead.
Yeah. So these are the things to know about this, right? I'm authenticating the request using IAM permissions, and that means I'm adding a SIG v4 header to my URL, right? The other thing is that this can run for up to 15 minutes, so my data will have to be pretty large to go over that timeout, right? What I'm actually querying is the Serverless Espresso application. I'm querying all the orders that we've ever had from Serverless Espresso in the last 8 months or so. So I think there's about 16 to 18,000 items in this little table. So I'm going to go over to the demo now. Let me zoom in like you guys asked. How's that? Can we see that?
Yeah.
So this is my function URL here, and this is generated by the Lambda service. And you can tell that it is because it has .lambda-URL and then the region that this Lambda function exists in, right? And I can simply just send a get HTTP request. The other thing I wanted to show you was my header in here. If I go, oh, I'm so zoomed in now, I can't see it. Yeah. Here is my SIG-v4 sign request. And that's nicely embedded into the header. And now I'm going to go ahead and make that cool. And you can see it's going to take a few seconds because this is essentially a cold start of my Lambda function, right? You remember, it's going through that front-end API. It's finding an execution environment. Hasn't found one because I haven't run this for a while. It's spanned one up. It's run the code. It's scanned the database, and it's returned that to me. And it's taken more or less 4 seconds, and it's about 1 meg, right? So a really simple way of invoking my Lambda function. I'm going to go back to my slide and show you what I'm going to introduce next. So, Lambda response streaming is something that we introduced, I think, a couple of months ago, and this is a really interesting feature that Lambda has now offered, right? This allows you to stream responses back from your Lambda function to the client, okay? And you can stream those responses in chunks as soon as they're available to you. So, this is what it looks like, right? I make my invocation to Lambda or service A. That might call downstream to service B. And then the response starts to get chunked up and sent back in buffers or in chunks as soon as it's available back to the client. Why is this useful? What use does this have? Well, 2 things that I think really stand out as to why you would use this. The first is that because you're chunking your response back, you now have a 20 megabyte payload limit of response, right? So we've gone from 6 to 20 megabytes of response payload limit. And you have a much faster time to first byte. So that first response comes in way quicker when you're using response streaming versus waiting for the entire request to finish executing before you return it. I'm going to jump back to my demo now, and I'll show you the comparative time between running the same scan query two different Lambda functions. One is returning my data using response streaming, and the other is returning it using what we call now buffered streaming, right? So I'll go back to the demo here. I'm going to run. On the right, we see my Lambda buffered response, and on the left, we see my Lambda response streaming. Pay close attention here to the time to first byte and the payload, okay? I'm going to invoke them at the same time. I've actually left my terminal open for you down here, so you can see that response as it's coming in, right, in real time in those chunks. And if I scroll down, what that's doing is that's paginating the data. And you can see this one took 2.5 seconds to get that first chunk of results back. This one took 9 seconds in total to complete. So I've got instantly a visual understanding of why I would use response streaming to return something more quickly. If I go back, I want to show you one more demo, but I just want to set it up and explain it first, right? I'll go back to my slides here. So what I showed you there with Lambda response streaming is interesting because we can see we have a faster time to first byte, but we're not actually doing any compute, right? All we were doing there is grabbing something from a DynamoDB table. So it's not very dynamic. You probably wouldn't always need a Lambda function for that, and we like using Lambda function to run some compute, okay? So let's return a dynamic response. In this next example, what I'm going to do is I'm going to grab something from an S3 bucket, and that something is a MP4 movie file. And I'm going to overlay some text on top of that file. And that text will be provided to my Lambda function via my function URL. So imagine you want to generate videos on the fly with overlay, or you want to insert adverts into the middle of your video, right? This is the method that you could use. If I go back to my demo, please. So on the left here is my original video. I'll play that to show you that it's a real video. There's no text on top of it. It's just me going through the serverless workflows collection. And on the right here, I'm going to add a watermark or an overlay on top of that video. I'm going to say hello from Lambda, and I'm going to generate that, and that's going to send back the response from my Lambda function in real time, pretty much. So I click generate, it's streaming back the response, and you can see underneath here the buffer that's coming back to my Lambda function, and I'm actually able to play this back in real time before the rest of the videos even finish generating, right? Now it kind of buffers a bit because maybe the player head gets a bit ahead of itself, but you can see here I have my text overlay. And there's one more thing I wanted to show you in this, if we have enough time, and I'll zoom in here for you, Jessica. Let me shut this side bit down. Oh, it's so difficult to see, isn't it? So this is the bits I wanted to show you, right? You notice that I provided some text to that. I think I put hello from Lambda. Now, the way I access that text is by using this event object.query string parameter. Now, this is how I get the query string parameter from my function URL. It's just added, question mark, watermark equals hello from Lambda. That's how it arrived in my Lambda function, and that's how I retrieve it here. And I save it to something called text, and then here I'm using ffmpeg to add that text, give it an X and a Y position, a font size and a color, and that's how I then pipeline here to stream that back out to my Lambda function result. And you can see that's still spinning at the bottom there. And there you go. I'll go back to my slides. Eric, did you have a question?
No, I was saying that's cool.
Oh, thanks.
Yeah. Is that cool?
That's
that's
cool.
my question.
Yeah,
It is cool.
Yeah, there you go. That's what I thought.
I like it. I enjoyed making that, actually.
That's really slick. I hadn't seen that yet.
So that's essentially it, right? Lambda response streaming, function URLs, and faster time to first byte, 20 megabyte payload limit.
It's fantastic. Ben, really good work here. It's interesting to see. I mean, we're getting to where we can edit video in web page, right?
In real time.
In real time, exactly. Really slick.